Day 10. I lost track of time, so I'm starting about an hour late. I did look at the problem beforehand, so uh, I do have a little bit of knowledge, but you can see I haven't actually started. So, my view of this problem is basically it's going to be a graph problem. We're given a bunch of symbols to represent pipes, and you have to be able to find, given a single location, that single starting location, find all of the cycles that lead to it, and you want to find the distance farthest away, which is going to be half the size of the cycle. So given the graph, find all the cycles, with the special caveat that this S could be any pipe type, and we don't know what. So as long as it connects into a pipe, a cycle, we have to find out all of the possible variations. And yep, it's a graph problem, so this is going to be kind of large. So what makes this difficult? I think a lot of things. So the same spot can appear in multiple cycles, I think. Let's see. So this is the beginning spot. The rules for the pens, wait, south and west. Okay. Okay, I see now. So 7 is yeah, top right. So this pipe would look like, well, actually, after that, I don't think you can do anything. Oh. Okay, actually, I'm not sure how this one gets anywhere, but okay, because S could be any shape. So what shape would be the most beneficial? If it's a cycle, it must have at least 2 exit points. Is that true? Let's think. Well, it's not possible for any shape to have more than one entrance point. So I think it's one entrance and one exit. Right, because these connect from one place to another. But nothing connects to 7 from this direction. From the right hand side, from east to west. So that can't be the direction we go in. What about here? You could do that. So it's a matter of finding out which of these makes sense. And to me, this makes no sense. So I assume we have a pipe that goes upwards. But again, the shape is very... It's not what a cycle looks like. Wait, this looks different from before. Am I crazy? Yeah, that looks different. Look, there was an F, there was an L here, now it's an F. Not sure what I did, but okay. Okay, let's look at this one. So again, can't be this way. This doesn't really make any sense because that's not a real path. So I'm going to assume it's not that one. Is it different every time? No, it's the same, right? No, that's different. That's, oh wait, no, okay, it's the same, right? So, starting from S, what are the possible shapes we have? Maybe I'm misreading this. See, these other examples make sense to me. We have, this would be an F, I think. That goes from here. You can look at the shape, and the shape makes a lot of sense. So that's the cycle. Maybe I'm misunderstanding how it works here. I mean, you can't do that. That just doesn't work, so... Yeah, none of these look possible to me. What am I missing? Okay, because there's only one exit and one entrance, I thought this would be about finding multiple cycles. But in the end, I think there's only going to be one cycle. Because you can't have diverging paths. It's only going to go one way. So the only challenge is to find out which pipe you start with. So that makes this actually a lot easier than I thought. But of course, I don't understand what this input is doing. I don't see how this results in any cycle at all. To me, it looks like you can't even go any of these directions. Well, I'll at least do the small case. Just to make sure we have the correct input, which I think we do. Yeah. So I need to find S and check out all the possible pipe shapes, and there won't be that many, I think. In this one, I think it can only be F. Otherwise, it doesn't have 2 inches and 2 exits. And luckily, S is not on the edge. In this one, it's in the middle. Wait, maybe zooming in is changing the problem. Oh, okay. I see now. So I was zooming in. That changes how everything appears, I think. Yeah, because that changes what's next to what. Okay, that's why we were getting impossible results. I was like, there's no way. Okay, that's a relief, right? Okay, that also explains how we had the problem input look like it changed when it obviously didn't. So, what are the possible ones we have here? Well, it's that. So S is F now. Okay, so problem solved. Yeah, and there's all sorts of little pipes we got going on here. Yeah, okay. So now we know S is F, just in that case, and this case. I wonder what part 2 is going to be like. Okay. So, I guess what we have is, you want to know the cycle length. And we want the coordinates of where S is, so we'll just do a little loop to do that. P for pipe. I don't know. So let's make sure we got that. Zero, 1, 2, and 0. Okay, now we have that. Let's just assume that it's F, so the first F is going to be going down. So I guess the thing that we want to do is to find a way to go from one coordinate to the next. So we can do that given a shape, I guess. So if we assume that the S is going to be F as well, the shape is going to be F, because it will be. I think the first thing we're going to do is just go down one, and from then on we'll have a function which returns, oops, I'm not sure what this returns, maybe a pair of coordinates. Well, how about this? It's maybe a pair of coordinates. Given the grid. And an X and Y. So I think how I use this is that, well, cycle length will just increment by 1. X will be, we can just go down 1, and leave Y as is, because the shape is going to be F. And then we say while X grid X, Y is not equal to S, we do cycle length plus plus, and then we well, let's look at next shape first. If we have a result, then we can tie to the result that updates X and Y to the pair value we're returning. And I think this always happens. We always increase the cycle length. So maybe we should do it once afterwards, just to account for the fact that if we get to S, we're not going to increase the cycle length. Possible. And it's kind of annoying. It's 3 separate instances of the same thing, but alright. And then, yeah, so that updates X and Y to whatever next shape brought us. So next shape will fail when well, you know, maybe it never fails, actually. Yeah, I think we'll actually just have it always succeed, so. So, well, maybe it's best I start cycle length at like 2 or something. That would get rid of these two. Why not? Let's just try this out. So now the real kicker is writing this. And at the end of this, we want to print the cycle length /2. That's as far as you can get in a cycle. It's going to be the midpoint. So if this, we can do a little switch here. Well, let's do it in order. Alright, if we do it like that, then we don't have to do any extra things. So if it's a pipe, we go one horizontally, vertically, which actually means doing that, yeah. This is kind of an annoying way, right? And if it's horizontal, we actually increment the y, just because of weird conventions. By 2. No, by 1. Right. So if we're on F, then the direction matters. I just realized that. Oh, okay, actually this makes this a lot harder than I thought. So if we have F, which essentially is a pipe that looks like that, if we're coming from this direction, the result is here. But if we're coming from this direction, the result is here. So I can't just inspect the current shape. I need to know the direction I'm coming from. And how will I know that? Maybe I could keep track of it. So each of these cases is a little bit different now, depending on the direction. I don't know what else to do though, so yeah. Oh, that's actually not that big, right? Right on the edge. So if we're going up, then we want to return y minus 1 with the same value of horizontal. Yeah, I know x is vertical and y is horizontal in this, and that just kind of makes no sense, but whatever. Right. So this means down. Yeah, okay. Do I even need that? Yeah. Oh, best to keep it. If we're going left, if we're going right, then we want to move one right. Otherwise, we go one left. So we need a new direction as well. So direction has to be one of our values. And we're initially going down, I think. Or maybe we're not. Well, let's just go down. This is too big now, but oh well. Okay, so these ones are simple. Now let's try something a little more interesting. So the L case is, well, let's mute these for now, they're giving us errors. The L case is if we're going left, then we actually end up going up. But if it turns out that we're going down, then we end up going right one. Wait, sorry. Right one. And our direction is now going right. Yeah. Okay. If this doesn't work, I'm just gonna give up, I think. If we're going right, then we're now going up. And otherwise, we must be going left. Right. If we're going right, now we're going down. Otherwise, now we're going left, and we go left one. For F, we were going left, now we're going down. Otherwise, now we're going right. Okay, if you get to dot, that means we messed up. So, I was just gonna say dots. lieu of an actual error. Okay, we're just gonna go with it. Oh. No matching token found. Oh. Yeah. No, it goes on forever. Okay. Oh. Never mind. What I was expecting to happen is down. We go down, left, that. Okay, so that doesn't happen. Understatement of the year. So I would like to keep track of our X and Y at least. I don't know if it still does writes, if it crashes, but oh, yeah, some of these aren't going to return anything. Okay. So I guess I could return some garbage for now. But it's not great. Yeah, so that's why I wanted to do optional before. Okay, so now it just runs forever. So we got to a dot at 4.2, which is this one, which we should not have gotten to. So we went from 2.0, okay, to 4.0. That's here, yeah. 4.1, and then we go to 4.2. So that's not correct. So let's put our direction out. If I even can. No. So our directions are up, right, left, down, I believe. Right. So this is left, this is right, and that's up. So J says if you're going right, you should be going up now, but it doesn't do that. Oh. Well, that would be because, yeah, I messed that up. At least I think I did. No, wait, that's not it either. Yeah. Okay. going up actually means subtracting 1 on the x. So I think all of these are, wait, did I mess that up? Up, right, left, up. That means going down. That means going left. Going down. And that, okay. Wow, what a system. So wait, what are we even looking for? So the answer is 8 to that? Hold your breath. Really don't think this will work, but oh, okay, cool. Oh my god. That's why only 2,000 people have solved this. It's weird. Okay, I haven't even read it yet. Let's see. Okay. Wait, is this calculating the error? No way. Oh god. You know, I would honestly just say I don't know, because I don't know. How do I know what's inside the loop? This sounds pretty difficult. Like, this is actually easy. I just started an hour late, so but this is something else entirely. So this is a very easy graph problem, actually. Obviously it still took me like 50 minutes, but I was, this is going to be very different though. I'm not sure how I'm going to, well, actually, let's rename some stuff. I'm not sure what is going to happen for this one. I probably have to rename that. No, I don't. Right. So we're going to do something forbidden, and I'm going to modify this grid at the x and y we're at, and just replace it with that. And then at the end of this, I'm going to print out our I'm going to print out what the grid looks like at the end of that. And I'm doing this so, oh, well, it's going to lag, but okay, wait, what the heck? It never finishes, right? Oh, yeah, I'd have to do it after, I just realized. Well, right. Fine, I'll do it like this. There. That should keep the original safe as well, so yeah. You know what? I'm gonna take that away for now. So this, whoa, okay. I believe this is roughly the area I have to calculate. Sorry, this is the, okay, that's the path. All of these exclamation points are paths. So the area is going to be the stuff inside of it. And gotta respond to a text, and I'm not sure how that's going to go. Okay, so area is going to be these little bits. Let's look at the example again. Okay, so maybe we can tell if a spot is inside by, if it's surrounded by two walls. No, wait, that's not right. Maybe if in all directions it's surrounded by a wall. Is that it? That's simple. No, wait, but that, no. It just can't be, well, maybe it's every single neighbor has to be connected to something which is also inside of the wall. I mean, so in this exact instance, this obviously can leak out here, right? But this, I mean, everything that's inside of here is definitely inside. None of this leaks out, that's to say. So the challenging cases are these little pockets. These pockets that leak out, I won't be able to determine easily if they're inside. I think I could actually count this one. Like, there's not that many. I could just be like that 1, 2, 3, 4, 5, 6, 7, 8. Like, there's not. Well, it'd be annoying to count that, but I do wonder if there's ways to do this easily. So one thing could be to require that for you to be inside of an area bounded by the shape, perhaps, hold on. Let's think. So what I don't want to do is do exactly what I said before, which is like to check if this is an area, all of its neighbors and everything it connects to has to be outside, because then I would look at all of these, and then I would do the same thing for dot, and then this, and then that, right? And that's very, all that would do, I don't even know if that would do anything. There you go, take that. But no, yeah, so the easy cases are like these, where everything is in a cage. Maybe I could find the shape of, it's possible I could, okay, let's think of a different graph problem. One that takes any of these, takes all the coordinates and stuffs them into a map. And I have a vector of these maps. And what I'm going to do, no, not a vector of these maps. Maybe I could just find all of these up until I hit an exclamation point or an S. Just go with all the neighbors and look And if for all of them they're not on the edge, no. Yeah, very area. I don't know. I don't know. It's kind of difficult. Maybe there's other rules I can think of. Like, nah. It's just we can't use the fact that it's bounded on all edges. That's not enough. We could use corners, but that's not gonna show everything. Like this is bounded by every direction except for like the bottom, the right, and the bottom right corner. And if you just extend this haphazardly, you will eventually hit a wall, and that tells us the incorrect answer. So, oh, that's difficult. Maybe I could, okay, maybe for each pocket of pipes, I could, excuse me, for each pocket of pipes. Wait, what if I know? How do I know something isn't in my wall? Let's see. Could I get rid of all of these on the outside and just... Oh, maybe I could do that. Maybe I could say everything on the outside. That's definitely not part of my wall because it's like outside of it. So everything that connects to this, instantly just start getting rid of it. Okay, so once I do that, then... Oh, I think that's it. Maybe... Well, let's be careful. What I mean to say is I will do this out, and I will start at the beginning. And I just want to explore all of these neighbors. So I guess it's a queue, maybe? I don't know. Yeah, my graph theory is very poor. I'm not sure how to explore all of these in a normal way. I might just do it how I know how. So we have a starting point of x equals 0, y equals 0. So that gets us here. And then I want, what do I want? I want to check all of its neighbors. So up, right, left, down is what I want to look at. So if our x is under a certain threshold, okay, so I think that would actually solve this. So start at a point that you know is not in the area, which in this case could be here, right? And then just start poisoning it. Just delete everything that it comes into contact with, as long as it's not an exclamation point. Because right, so that'll get rid of all of these, and at the end, let's say I replace them with hashtags or something, like that or something, right? And at the end, what I'm gonna have is just the pipes that are inside, because the pipes that were inside did not get touched. So instead of finding the area, I want to find everything but the area, which I think is actually a much easier problem. The problem is I don't really know how to do it. So I don't know. I can think of really inefficient ways, but obviously those are inefficient. Haha. You know what? Whatever. I think this should be a queue. Something tells me that this should probably be a queue, but again, haven't thought about it hard enough yet. So while we haven't exhausted all of the neighbors, so if that means that, we can push a new, oh wait, and the current square we're not on, oh, whatever, right? We can put a new neighbor in here. Oh, goodness, right. How about this? We start at 0, 0. And then what happens is that we keep looking at the back, and we say that if we haven't set it to like some missing symbol, which we'll use hashtag for, then we push in a pair of x plus 1 and, you know, y plus 1, stuff like that. So I did too many checks in this one. I don't need all of those checks. Else, and I want to do that for all of these, so it's not actually else if. So that's the big case. We can do the small case. And we can start doing some fun mix and matching fun. Alright, that. And we can do of this. Whoa, 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 whoa. Right. There. So that gets, actually I just want upright and left down, so maybe we got that. Man, I might have done too much work this time actually. This probably doesn't work just based on the fact that there's a lot of, even now, only a few thousand people have solved it. I mean, I assume people gave up because it's 2 a.m., but if I started this at 1, maybe I would have had a really good score. Who knows? Well, let's not get ahead of ourselves. Let's actually solve this. And yeah, I'm very, very unconvinced that this is gonna work. Just, it's too simple. So that puts in all of our neighbors, which is what I wanted. So what happens now though? So what stops me from putting back these neighbors? Well, I need to make sure that it's not already equal to our symbol. And then once it's that, and I will set it to being as marked, it means I'm done. I think. Who knows? And yeah, this is very error prone again. And I don't know, I'm a little concerned if I only check. Oh well, whatever. If I only check the I have to think about this some more. I feel like if I only check the directions right next to me, that might not be enough. I might be missing some pieces here. And you know, there's the whole probably this isn't gonna work portion, but that's actually less of a concern right now. I just want to see what this looks like, honestly. Something like that. Okay, so what I want is all of the non-area to be hashtags. Therefore, all of the remaining pipes. Okay, it didn't work. Right. Boy, this is taking way too long. let's try it with a small input. Deep breath. Doesn't work. Okay. Oh, well, hold on. It also has to not be exclamation points. So let's make sure we're still doing that right. Well, that one doesn't look like it has a lot of area, to be honest, so let's go with this one. Right, so honestly, I could probably do that. Yeah, still getting the correct answer, right? Yeah, okay. So that just makes things slightly easier for later, I think. So let's, oh wait, is S still in here? It's not. Okay, so the area for this is like 1, and that's it. Okay. Area for this is okay. So my goal is to color all of these dots with a hashtag, all of the dots that connect to them. Therefore, to do that, I need to figure out a condition, but hang on. Yeah, okay, so where are we? Oh, well, I never popped the neighbor off. That's my problem. That means I've consumed it. Okay, well, that didn't do anything now, right? Well, these should all be not equals, but yeah. Out of it, what? Oh, whoops. Right. Well, actually, wait, that has to be true as well. Also cannot be marked as used. This is a lot of conditions. Okay, let's think. No, it's still, wait, what, why? What if it, okay, well then it does nothing, right? So if it's not a hashtag, And it's not an exclamation point. Do that, right? So why is it doing nothing? Why is it doing everything? Okay. So, well, hold on. That's a 1. I meant to say that. Right? But that shouldn't change anything. So, whoa! It did it. I think I just solved this. No way. Oh, god damn it. Okay, so there are other corners to this. So now I'm going to have a new function that's going to do all this, and I'll just give it coordinates to feed into itself, if that makes any sense. So instead of 0, 0, it starts at x and y, and I can call this for the grid 0, 0, because I think, well, theoretically they could make it really annoying, but I don't actually think it's that bad. So like if I just do each corner, I think that's actually enough. Expect a bunch of hashtags. Come on, come on. Huh? Oh wait, whoops, that's not the corner. That's the corner. I mean, oh shoot, there's one more case there. That's at, just gonna remove that manually. 50. Yeah, I'm not doing that. Right? Right. So good. I mean, okay, well, let's actually make sure it's, still works, and I really don't think it does. So, I mean, that looks. Oh yeah, see that? Well, actually, wait, that's only because of it. So this is gonna work for different inputs. I think this only works for mine, because like, yeah. Well, we could, you know what? You could check off the border. That's, I actually think that's a fair way of doing it. So, this I think is actually, it's not as efficient, but I think it's actually a fair way of doing this. And it's the same amount of lines, so yeah, there you go. My rules, right? Yeah, I think that took a little bit longer, but theoretically, we should actually do this now. Yeah. Hey, whoa, what's it doing? It's filling the inside too now. Oh wait, I went through every single square. That's not what I wanted to do. I just wanted the borders. do need that, yeah. I always try to do one-line for statements, and they just never pan out for me. So, yeah. Yeah, okay. That looks okay to me. Now, for the final test. Well, not the final test, but you know what I mean. Goodness, this has taken a very, very long time. I'm quite tired. For every line inside the grid, for every pipe inside the line, if pipe is not equal to hashtag and the pipe is not equal to exclamation point, area should get 4. Very interesting. Don't want to celebrate prematurely, but oh, wait. Huh? Correct answer for someone else. That doesn't sound like it's a possible error to have. How could I have, okay, close that. How could I have the possible, how could that be possible? What did they say? Oh, wait, just lucky, okay. Where was I? Alright, so let's... It's too high, really? Too high. So I must be counting area that I should not be counting. Does... Oh, I understand now. Okay, so you know what? This wasn't enough. It's possible to have an area. Let's say we have a grid. Oh, I don't want to draw a grid. But I'll do it anyway. Well, actually, I need a bunch of these. Yeah. I mean, let's think about this for a second. If we have a grid, that's, what is that? Just gonna pretend that's all one line. Hey, if we have a grid and it does something like... So that's an area of 0. Area of 2. I suspect it's possible that you could do something like this. Wait. No. I think it's possible though for you to create a shape or a path that doesn't actually result in yeah, so I think they deliberately made this kind of difficult, but I think it's possible to make a path that makes it so that my conditions for finding out what is and is not connected don't apply. Probably. Like, I think you actually need to have a little, like a loop like that for it to count. It can't look like, how do I describe this shape? Very difficult for me to describe the shape. You know, something like that, where the area is actually all this stuff. It's not. It's not actually. So imagine that this square, I don't think this square would count as area in that case, even though it's, because it's not inside the loop, right? The loop is all this stuff. This is the actual area of the loop. So that's probably what's getting me. And that can be done arbitrarily, so it kind of means all my work is useless, so yeah. Okay. I don't know. This one is very advanced. I don't know if I can get this. Answer was too high. Somehow it ended up being the exact same as someone else's answer. I mean, what are the odds of that? So yeah, I think that's the problem, is that you can have a graph which creates this like really advanced shape, but it's not, but the area of it isn't what you expect. Right? Like, what's the area of this? It's not that. Well, actually, this one happens to leak outside, but the area isn't that. It's this stuff. So that could be done arbitrarily, and I have like no way of telling. Not with this, especially not after I did this. I don't know, yeah. Like let's look at the actual input. So go to 67. Huh? Wait, what is that? Wait, why is that appearing? Oh wait, no man, there's a line up here. Okay. 68. Oh, 66. Okay. So if you're something like this, the shape of the walls, let's look at that. So I want to make sure this is actually in the area. I think it is. Ooh. Maybe it's not. Yeah, so I think it's the actual definition of area is the problem. That's crazy. It's the same answer as someone else's. I can't get over that. Well, oh, wait, no, they had a better test case. I should have done that before. So now if this is wrong, we should have a very easy explanation as to why. No, that's not true, but great, it's correct. Well, that's not very helpful. No, I still think that, okay, well maybe I can try to, I don't want to draw a test case, that's annoying, but maybe I have to. Start with the grid. So S, and I assume it's F, so maybe that's my problem, honestly. Does that matter? I've been assuming S is F, just because it has been. Let's make sure in this case it actually is. Oh, there's no S in it. Okay, other. Yeah, the test case won't actually be F here. It's going to be, well, what's important is that the move is going down. Yeah, so it doesn't actually matter. Yeah, so never mind. Doesn't matter. Great. So I gotta figure out exactly what it is I'm trying to say about this. So let's say we have a pipe that goes here. So what I need is to create a double wall, essentially. No. What is it to go left up again? J. Wait, you know what? I changed my mind. I mean, that's a wall, right? Originally I was thinking that this wouldn't count because, so, wait. I was thinking this might not count because of this reasoning, that you could have like an inner wall that isn't technically in the area. But I think it actually does still count. I need to draw this out a lot more clearly, so I'll do that. could have just downloaded the grid by now, but whatever. So, yeah. From this point, yeah, that should be enough space. So what I'm trying to say, try this out very concretely. I already ran out of space. Wait. Maybe I can do the tiniest example possible. So that's fine. But what's that? That is actually an area. I should do that. But no, that's also an area. So what was I trying to say before? No. So the area is that, but maybe is everything that's not outside the shape inside the shape? That's the question we have to find out. I can't imagine how I got the correct answer for another test case. I mean, what are the odds of that? Right, so you know what, this is almost what I mean. This gap, if there was a block here, no wait, that would actually be caught as not being inside. Oh, goodness. Wait. I think I almost understand what my test case is here though. Perhaps it's more of the problem like this. Let's keep it here. Now that results in an actual area. So does that. I mean, I don't know why I'm doing this anyway. If I prove that what I'm trying to do doesn't work, that's just gonna make me give up, so. I'm gonna consult with someone else, see if they agree that this test case is a real problem. Let's see if this grid opens. Move that here. So this is the true area. Move that over here. Okay. But if I just binary search the answer, like I guess like 600 or something instead of, 600 and whatever. Okay, I'm just gonna do it just to see what happens. What if I do like 595? Okay, now it's still like, I'm not gonna, well, I really shouldn't do that. Wait. So I think, okay, it's just bad luck in that case. Okay, so I think I figured out that's probably the problem. This is a really bad diagram, but you can create a shape which has an actual area, but it's possible to make this an interior that's closed off to the outside. That's the edge out here. The stuff that I would replace with hashtags. And I can only replace stuff with hashtags if I know it's connected to the outside, because that's how my neighboring system works. So if there's no path to get to it, then there's no way for me to determine if it's part of the shape or not. Because the path could just be in this very specific direction where the inside of the path isn't found. At least assuming that's what I meant by enclosed. I should read this again. Yeah. So, a better example is honestly this, but instead of having it be shaped like that, okay, I should have just done this the whole time. Yeah, so this is what I mean. I don't know why I did it like that, but yeah, like this isn't, but I'll get the wrong answer. I'll get 15.
Okay, well, I mean, that's about as good as I can do. There's no way I'm solving this, I think, so probably gonna give that up. I mean, is there anything that distinguishes this? Well, let's do that. Anything that distinguishes these two. I mean, the direction of this goes like that. Whereas the direction of this, it doesn't tell us anything. For all we know, it could just be part of the shape. There's no way for me to tell that, I think. Like, maybe if I looked at all the edges, there'd be something that could tell me, but... I mean, it's a good start. Maybe I can use this information somehow, but... So we know that if we're here, we're inside of a bunch of paths. Now the question is, do these paths... Are we inside of the path, necessarily? So maybe I did transform this problem into something easier, where I can look at a group of these and determine if we're actually inside of the path. So what is different about this versus this? Well, one's inside the path. No. Perhaps I could keep a direction of the... For now, like, there's just no way for me to tell immediately that this is the true area. That was loud. But maybe I could... No. Yeah, I'm probably just gonna give up. But not before trying another answer just for fun. Wait, what if it's secretly like 580? Okay, no, it's still too high. Yeah, so I gotta cut out at least 21 answers inside of this, and that's too difficult. I mean, that actually does tell us something, so I need to cut out at least 21. Like, who knows, maybe this whole thing is not actually part of the... It's possible that this whole thing is not actually part of the area. Like, it's surrounded by the shape. Did my friend just complete part 2? Let's see. Oh, no, I think that was part 1. Let's see how everyone's doing. Oh, he did? What? How? Wait, that's crazy. Right. Yeah. Okay. Well, if there's no easy cheese on this one. No, wait, not of a graph, of a... No. Oh yeah, well, these are all useless. Well, it doesn't have to be directed, it could be undirected. No, okay. Yeah, well, it was a good effort, but I think I'm not gonna do that. Actually, you know what? Wait. How am I even getting that doesn't even look like 601. Maybe I'm just prejudiced, but that doesn't look like 601 to me. That looks like it should be a lot less. Kind of calling BS on this. I want to see. Was that really? Yeah, I guess that is 601 things. Okay. Yeah, I have 100 lines, and on each line there's at least, like, yeah, a bunch of things. Okay, so that is actually 600. Yeah, I don't think there's a way to do this without checking directly what's in and outside. So I think you need to use an actual graph algorithm for that, and I don't think there's a way to cheese that. Oh, that's not going to stop me from submitting like a totally random answer, you know? Like I did 580 before. What if it's like 560, you know? Okay, so now it's no longer telling me, I think. Yeah, because it wasn't guessing. Okay. So yeah. It was useful though, so I know at least 21 of these should not be inside, because I got down to 580 from 601. And yeah, there's not, if I'm looking at this, there's no indication of which one it could be. And even if I had the direction, the only way to know for sure is if there would be like a pipe structure that would lead it to the outside, like this. But that pipe structure isn't going to be straight. It could be going in any direction, and that would just be annoying. And who knows how I would even get that. Well, this is a good try. Okay, till next time. Hello, we're back. I could not do day 10 in time, it's the 11th, so I was shown how someone else did this, and what they did is they used something called Pick's formula. And Pick's formula finds the area for any given polygon, if you know enough information about it. It's this formula right here, which is to say that the area is equal to the interior points, that's I, plus
the perimeter, that's b, the boundary points, divided by 2 minus 1. So what we want is the interior points, right? Because that area isn't going to get us what we need. We want to count the amount of things which are inside of a polygon. So if we do some algebraic reordering, we can take that 1 over, right? We can like add that. I think that's really how algebra works. And this b used to be added, now it's going to be subtracted. And now we can put this on the other side, and bam, there's our, there it is. That's how we find the interior point count. It's going to be the area plus 1 minus half of the perimeter. So how do we find the area? Well, there's something called the shoelace formula, which given all of your coordinate pairs, if you find the determinant of them in this fashion, you have double the area. Therefore, you just cut it in half. As to why that works for the determinants, I don't really know. Not a linear algebra guy, but this is fairly simple to implement. So, I keep track of the coordinates. We start at s, which is just x and y, after we find out where it is. Then we increment by 1, and then we do the same thing as before, where we just go through x and y, follow the pipe, and we push that into our coordinates. Then at the end, we have a determinant sum, and we do a times d minus b times c. That's how it works there. And you can see at the end there's some weird stuff going on here. That's just because for the last one you have to wrap around to the beginning. Exactly where I'm not sure. I know that this is supposed to form a cycle, right? Because it's a path and it must be an interior, but not entirely sure why that works. So anyway, we can still fill in the formula, which is, that was an email, which is this. So we take the area, which is going to be half of that determinant sum. We know the perimeter is going to be the amount of coordinates we have. And the interior points, as we said before, was area plus 1 minus half the perimeter. And once we do that, we do indeed get the correct answer. And it doesn't take very long. 14 milliseconds, that's very short. So now I finally have everything. Although that's the first one I've had to wait a day on solving. Till next time.